All right, so why am I recording? Okay, welcome if you're here locally or here remotely. Like I said, I'll take a picture of this, I guess, but the idea is the tech talk is 15, 20 minutes, kind of informal. And I'm just here as a fellow developer today because I thought the best way to demonstrate a tech talk was just to do one. So I spent, I'd say, a good hour or two on this, not a lot. What I'm showing off today is an old project that I built for C# called the MazeBuilder. So let me walk you through what this thing does and at the same time kind of show you back to the beginning. All right. Okay, so we're in. So this should be recording. So as I started off writing this yesterday, I want to demonstrate an informal code review. And then as you can see, I had some problems. So what I got to do is demonstrate that my dog likes to, that's Esther, so hello Esther. What she did was, it was near time for her to eat. So I'm typing along and she takes her chin and just puts it on the keyboard and starts pressing keys. So had to wait until after dinner to finish this up. But I wanted to use a real world example of an actual program I'd written to show you what this demo is like. Again, these documents are not super formal. You guys, I'm not going to do any kind of a burn down chart or velocity because this is a finished product. What was this? So here's the book. It's Mazes for Programmers. Pragmatic Press is pretty great. Pragmatic and No Starch are probably the two no BS publishers I would go for. The examples are all in Ruby. I don't speak Ruby. Not a lot of people do. It kind of it was big for a bit, then kind of went away. But when you look at the code, especially when you look at the classes and the way they were organized, I was able to use the same format. And it was well-commented code. So this was a demo I did for CSC 253 C# back when I was teaching that. So it's been like 2016, I think. But the idea was I might want to lead it into a larger kind of mud or text adventure type of game, maybe a roguelike. Never happened, but still could at some point. All right, what's the technology? So C# and WinForms. I noted when I wanted to rebuild this to do demos on this demo machine, unfortunately, I'm not running Visual Studio. So I'll just show you the code in Sublime Text. But I did rebuild it to confirm it works, and I had to reinstall the .NET 4.5.2 pack because they're on .NET 4.8 now. So I mentioned that because it's the kind of thing you're going to run into, especially on C#, is when you switch to a different version of, actually we've run into this, like if you switch versions of Visual Studio, you move to a later version of Windows 10, which again, Windows 10, you don't get to ask when to update it, updates for you. So you got to think about what's going to match. Turned out on this older machine here, I still had the old .NET, no problem. But on a fresh Windows 10 install, you got to go back and install. This is just a thing about .NET. It's the same thing with if you ever see Microsoft Visual C++ runtime. There's just elements that are required in Windows that are not installed by default. Okay. What does the program do? I'll demo what it looks like in a second. It's a simple WinForm program. And the form's going to grab, when I say marshal, that's basically just, take the user input and then go off and do different things, right? So from user input, go to a method call. That's marshaling your calls. So it goes to these different MazeBuilder objects, and they populate this maze. The maze is, originally it was just ASCII art of a grid, and that was a real hassle to do. So I dug in and did line graphics in a very primitive fashion that you would not usually do in WinForms, but it works to just draw the maze directly. So here you can kind of see what it looks like. Just through these, not a lot of great time on UI. So the workflow is not in here. So I can imagine writing a user manual. What would I say? I would say, okay, first you have to init your 10 by 10 grid. Then you might choose to display it. And then you would choose to generate a maze in one of three methods. I'll talk about what those are. The basic one is binary tree, which is sort of an old classic kind of 70s and 80s maze algorithm. To generate mazes. Solving mazes is a different problem. You kind of do push pop, where you say, okay, I'm standing here, I'm going to set a marker, breadcrumb, and go look in different directions. And you'll see when we do the distance from origin, there's a little bit of that still in there. So generate this. As you can see, each cell is just a box with 4 walls, and you would dig out a wall in order to move a certain different direction. So again, if you've ever seen any kind of roguelikes or any kind of maze in an RPG game, it's a little SMT-ish maybe, that you'd have that. All right, What's the data structure? So I recapitulate this in the data dictionary, but I've got a grid. It's 10 by 10. That was arbitrary, just to fit on the form. It contains cell objects. So each cell object has, you kind of see here, a row and column. So starting at 0, 0 down to 9, 9. You have each cell in a different location, and then you have references to neighboring cells. I want to say pointer, but they're not pointers in C#. But the point is there's a lightweight reference to these other objects, right? And so it'll know if there's a cell to the north, south, east, or west, and whether or not it can actually go in that direction. And then we have one variable to track distance to origin when we do the maze distance, which we'll look at the end if we have time. Okay, so originally the idea was me as a kid sitting in the Atlanta airport in like the mid-'80s reading a Compute magazine, and they had this article about building mazes. Unfortunately, I could never find that article again. I've dug around many times. Like the whole series of this magazine's on archive.org, but I just can't find the article. But then this book kind of does the same thing, right? The idea being to start off with a maze of cells that are all, the walls all exist. And you think of the metaphor being I want to dig a wall from like east to west, right? So if I dig from one cell to another, I have these two cells, and in this cell, if I dig an east to west passage, I need to also dig a west to east passage the other way, right? And now these two cells are connected. So that's the fundamental action. You start with a bunch of cells that they're unpassable, and you open up walls to make a maze. Binary tree is the basic one. I remember this is basically the maze algorithm they used to use in the 80s. You start off at the bottom of the grid with all these cells, and you flip a coin. You either dig north or you dig east. And you do this all the way across. And what happens is you end up with a maze that has, and this is not a perfect maze. If you want a perfect maze, I won't get into the details too much. A perfect maze has one solution. These types of mazes, there's lots of passages back and forth, so not like a kid's workbook maze where you're trying to solve the maze. This is more of like a role-playing game maze because you want to have multiple paths to different locations. So you dig this open, and then you just repeat as you go, and when you're done, you have a guaranteed path from one cell to another. And then at the end, you have to dig one exit because there's no way to leave this grid. The other algorithms, and again, these are just out of this Mazes for Programmers book. They had several others. Sidewinder generates these runs of cells. So you'll kind of see when I show you a Sidewinder, it has this sort of texture where, like if it were a game, you might say this looks like maybe like a mountain range because you're mostly going east and west and occasionally getting to go north and south. And then there's Aldous Broder, which uses random walk. Random walk is its own area. Anybody's curious, if you have the old Python book, there's a random walk section in there, I think, someplace. But again, I'm recreating, porting well-commented Ruby code, and I'm still not 100% sure on how Aldous Broder works. Like I know it does a random walk. I don't know when it's done. Because you can imagine if you random walked forever, you would just open up every wall. So I think it says when there's a certain number of passages made. Okay. Let's look at the program. Alt-tab here. Great. So again, sorry, I don't have Visual Studio on this machine, so I'm just running the program directly. Okay, so here's my form. You guys can hopefully see this okay. So I'm going to init the grid and then draw it, and there's my ASCII art. So this was a real pain in the ass to make it work. It was pretty much like, how do you make exactly one box? So if you're doing ASCII art, I'll say this is, it's pretty tricky. And so I had to say, well, I'm going to have this many characters across. So in order to make them look square, they're not square. They're like 4 by 2 or 4 by 3 because characters printed out in a font are rectangular, right? They're not square. And then there's also the bitmap version, which was a little easier to do. You can kind of see that update. So I just drew a bitmap surface and then used GDI calls, which is the really old like Win16 graphics, to just directly draw the lines on here. Okay, so that's that. Let's show off what happens here. So here's my grid. So let's do a binary tree. Now I draw the binary tree, and now I have to update. And there we go. And you see when you switch rendering, it just pops one on top of the other, so you can go with either one. So this binary tree, and you can kind of see what I mean about how when the binary tree digs, it either digs east or it digs north. So it's kind of a weird structure, right? But it's guaranteed to work. It's the most general maze program you can do. It's not a lot of code, as I'll show you. All right. Let's go back and re-init to a blank grid. I think this program does weird things if you try to maze build on an existing maze. These are all different classes, so I'll show you how the MazeBuilder subclasses work. Sidewinder. I'll actually do a couple of sidewinders to show you what I mean. That one's very weird. Oh, I need to re-init, sorry. Yeah, that's, like I said, if you do on top of each other, it's a bug. Yeah, Sidewinder not, sometimes not too exciting. Let's see here. Yeah, this is more like it. So you can see in Sidewinder, again, this would be maybe kind of an annoying game, RPG kind of maze. You have a whole lot of runs. So here, this is a run of 1. This is a run of 6. And it just draws these sideways runs. So when you're going through the maze, you're generally spending a lot of time backtracking left and right and then going north and south a little bit. So if you say had a game where north and south depended like how difficult the monsters were, that might work out well because you spend a lot of time kind of grinding across. Again, you see, if you were like a kid doing a maze, it's not that kind of maze. Those are typically perfect mazes, and they're usually best done by hand probably because there's any number of ways to get from one place to another in this maze. But for a game, pretty useful. I'll reinitialize and do algocratic. And this is probably the best. I'll do another one to show you. Algocratic, because it does this random walk, it's the least texture-y map. Like you can see, binary tree is going to have these always going up and to the right. Sidewinder has sideways. This, because it's a random walk, it does not bias. It's a random choice which direction it digs. You see it kind of just makes a sort of mazy type of maze. Again, this would be something you would use in a game. Like by itself, it's not very exciting unless you want to like just print it out. So let's go back to the ASCII and show you the one last feature it's got, which is kind of neat. So this uses an algorithm to calculate distance. And I think, again, it just does kind of a push and pop to say how far is things. And tries to find the shortest path to 0, 0. 0, 0 being here in the top left. There we go. So you can kind of see, it doesn't work on bitmap. I never got that far because you have to render fonts. But you can see what happens. I say, well, the distance from 0, 0 is 0 nearer than 1. But then it's actually tracing it. So this one is very high because you have to go all the way through here. Yeah, there we go. I got it. Cool. You have to go all the way around. And so you can see this is almost as far from 1, 1 as the far map is. So again, if you were doing, why would you want to do something like distance? Again, if you were making a game, you might say, well, I don't want the treasure chest to be next to the exit. That's stupid. So I might say only an area 15 or more from origin could be where a treasure chest spawns. With this, you are guaranteed that every cell is traversable. So that's another reason why I like these algorithms. They all open up at least one spot to every cell. Just what direction, we don't know. Okay. All right, so far you guys are with me. What it does is not super fancy. I'll do one more with a binary tree and do distance. And here you kind of see you don't have as much, like for the most part with the binary tree, where you are is about like, how far it is. So there's no like, no far off sections near the origin because the maze doesn't twist much. And then I'll just do one with Sidewinder again to show you what I mean. Cool. Same thing here. You can kind of see the distances are pretty static. Although interestingly enough, I think it's like a lot of these runs mean that, yeah, all these areas are pretty close to the exit because you can usually just go straight across. Or if not, you go up one, across, and down. All right, so that's the program. That's what it does. So talk a little bit about what's going on here. So I did some very simple diagrams for context and data dictionary because this is not a very fancy program. Cool. So I use draw.io. You'll notice when you go to draw.io, it's named something different now, but it still directs. And there are controls for this. This is not perfect. This is basically what I'm looking for. Remember again, a context diagram, you put 0 in the name of your program, and all you have is the external elements. Now, since I only have one external element, the user, it's very easy. You pick the maze type, go complete the maze. I did leave a few things off here, right? Because I should be able to pass in things like, do you want to see the distance or not, or what render type? So if I were drawing this to the next diagram, which again, I'm not requiring you to do at this point. If I were to zoom this in, I would have within it a couple of subsystems. I would have the form, which does all the work of rendering and UI, and I would have the maze builders, which operate on a data store, which is the grid, right? You can imagine how, similar to login, you act on a data store, then someone else uses it. Okay. Here's my data dictionary. As I mentioned, I've already told you the whole structure of the program. So a fundamental element is a grid, which is made of cells. And cells have the following parameters. So I don't store these mazes in a database, but if I did, it'd be easy enough. You just have 100 entries of cells, and it would just read them in. And again, distance to origin, we could just calculate that on the fly, but I stored it in the cells to make it easier to display. Okay, so one of the main reasons you guys are doing a tech presentation is stuff that you think is interesting, so I had to kind of reach here because it's a simple program. First of all, there's the question of, I have this grid, and I know where every cell is, but then I have references to the adjacent objects, right? And so as I've been picked on in the text adventure last semester in Python, that is a little bit maybe redundant, because if I know I'm cell 3.3, obviously I'm next to cell 2.3 and 4.3 and 3.4 and 2.4. So I store both pieces of information. So I have the location in the grid, but also the adjacent cell. I think part of the reason I did that was because, like I said, when you dig an entrance, you need to know who's next to you. And the math just got really annoying. Think about if you're at cell 0, you're on the edge of the maze. Well, I can't dig west because there's no grid there. So what I did was just not give it a neighbor to the west. So I never had to check. I could have also just checked every time I dug, is this number going to go less than 10, greater than 10 or less than 0? But I didn't do that. Because you could just say, I can move east or not, and that would work. The rendering was kind of neat. Like I said, if we look at the grid, I looked at the code they wrote in Ruby, and I kind of hacked it to hell. Because drawing a grid, like I said, it's not square, and you have to render like 3 lines at a time. It's kind of a lost art. There's a lot of old games in those 70s and 80s books that I have that are in BASIC that do this kind of rendering, but it was a pain. It was much easier to do the BMP, but it really was Stone Age. Like literally, I had written code in like the mid-90s for 16-bit Windows that did the same thing, because it's a GDI calls, like the graphics display interface. It's the most primitive way in Windows you could draw an image. You would almost always these days, load an existing image or something. But it worked, so, heck with it. All right, where might I take this if I were going to extend this product? Well, the thought was to use random dungeons. I mean, it's procedural generation. It's very much what a roguelike does. When you look at games that do roguelike, most of them often do Aldous Broder style rendering. But what I thought was kind of neat was, since they have different textures, you might say, well, maybe my indoor areas are Aldous Broder, maybe my outdoor areas are Sidewinder. Maybe the forest has lots of paths you can wander through. And that might give some difference in gameplay. But I never got that far. It was just the idea. And that was one of the reasons why, again, I had that redundancy. Because, when I write a text adventure, I typically say, this room you can go north or east, and then you check for go east, and then you go to that room, making a node structure, a map structure. But if you just wanted to have a square game world or rectangular game world, you could just use a grid, array grid, and just say, yeah, you can't go east from here. You can't go +1 from here. And when I actually dug into the code, one of the reasons I thought of this, I was digging around Avenia, which is a Python mud that we looked at briefly in the Python class. It has regions that are generated as grids, and then it comes up with the description for the room based on where you are in the grid. So you could kind of port that code directly. And my last thought, just to kind of reach out there, is one time I did kind of a Wolfenstein 3D type deal in grad school, real primitive OpenGL 3D graphics, but it was like a project I had to do like in a week. And it was just drawing a maze as a bunch of polygons, and there's no 3D to it. It's just like really like a Wolfenstein 3D. When there's a wall there, I can render this as a 3D graphic just by doing a perspective correct on it. So instead of looking at the maze from top down, you look at it from within if you added height to the walls. All right. So let's do a little bit of code walkthrough. If anybody has any questions, we'll kind of talk about that. So let me go in and just get into Sublime. The form, sorry, this screen's so small. So in the form, I simply initialize a grid here. And whenever you click Init Grid, I just recreate the grid. So I throw away the old grid object, make a new one. And the first one I did was the MazeBuilder. So what's interesting about this, and this, again, I stole this from this book, was the idea of having subclasses of the MazeBuilder object. I think actually my MazeBuilder was abstract. So it's just different MazeBuilders exist. There's no, binary, algocratic, or whatever. And what a MazeBuilder does is you give it a grid and it gives you back the same grid, but with the walls dug to have a maze. So that's why the form can just display that, because as you see, build maze, same thing here, nothing too exciting. The funky stuff, so the drawing. So you can see I had first take, and I just kept my first take, which was I drew a bitmap directly on the form and just drew lines on it, which is kind of gross in terms of being really, really simple code. It's like, it makes Python turtle look fancy. But it works. This is why things like a brush, you will never see brush when you do C#, but that's how we did it in the 90s. And I just said, okay, cool. So that's actually not broken, so I should take that comment out. I just took a pen and just drew lines in a grid. So you just said, this is a cell? Cool. Is this wall open? If not, draw a line. If it's open, don't draw a line. And I'll briefly show you no, I won't actually. Where is it? My text only might be in a separate file. It was pretty gnarly. But what I wanted to show you here, so the grid class, very simple. I'm using getters and setters here to say grab a cell. So the MazeBuilder operates on a grid, so it has to say give me cell 3-3. Okay, cool. I'm going to dig the east to that to 3-4. And again, I'm making this grid and then I'm putting an object in each of these. So it's not very efficient. Let's look at the basic MazeBuilder. So here's oh yeah, I did. So the base class does nothing but generate a random seed, and then it doesn't do anything. So as you can see here, I threw a not implemented exception if you actually call that. So I didn't make it abstract. I kind of cheated here. I just said the base class doesn't work, and you have to subclass it. So let's look at the binary tree one, because that's probably the simplest one here. I don't have anything special here for the seed, because again, it has its own seed in the subclass. Sorry, the superclass. You build the maze, and it just says here. So this is actually, again, I didn't do this. I stole the idea, but I like this idea. I'm going to operate on all the cells, so I just have the method do a nested loop, and then I just operate on each cell individually. So that way it keeps the code a little cleaner. And when you look at process cell, that's it. Like I said, binary tree is very simple. It either digs north or east. And of course, if you're on the edge, you can't dig east, or if you're on the top, you can't dig north. I flip a coin, or I do a random 20, and modulo that. I won't get into the boring part there, but C# has a severely busted random number generator. It's so bad they had to make at least one extra one. And the excuse Microsoft said was, well, the old one, if we fix it, it'll break a lot of old code. Which is kind of bogus, because if it gives a bad random number, like if you want to say, for example, write a piece of code where you roll a 6-sided die, you will get 33333 half the time. It's garbage. So I use a different generator, which is it's the encryption random number generator, but that's not super important. Sorry, I kind of got off on track there. And you can see I do cell link. So what's kind of neat here is, and you can see it goes to it, the cell itself knows how to link things. So I can see here it says, add a link, say east to west, and if it's a bidirectional link, go to the cell and add a west to east link on that cell. That's kind of the most fun in this code, the link and unlink stuff. Just for comparison, I'll show you algocratic, which is quite a bit more complicated. So it's not as bad as I thought, I guess. It starts in a random location, and it random walks digging holes, and it continues doing that until it's been to every cell. Because with a random walk, that's the only way you could do that. Now, you might think about a random walk. Okay, 100 cells, you could visit a couple of thousand. You could walk around forever before you get all 100, right? So this is not, strictly speaking, guaranteed to terminate in like a certain period of time. But reasonably speaking, the code's so fast, it's not going to be a problem. But it's something to think about with random walks. If your random walk stops when you've been everywhere, it might just not happen to go anywhere for a long time. It might have that one pixel in the corner it's missing. And then finally, I'll show you the distance. Well, Sidewinder is not super interesting. Distance calculator, what it does here is, oh yeah, this is what I forgot. Dijkstra's algorithm. So if you want to do anything with mazes, just look up Dijkstra's algorithm. That will solve any maze that's given in about as efficient a way as you can do it. And what it does is simply start at 0, 0 and just go every possible direction, right? So the way you would use it to solve a maze is you would start at the entrance and have it do that until it found a certain cell. What I'm doing instead is saying start at the entrance and go to every cell and just keep track of how many steps you took, okay? And the idea there was, you know, if you were writing an AI for like an NPC, you might say, well, the NPC always goes towards the exit. So it doesn't matter if they move from a cell within distance to a cell within -1 distance, they're guaranteed to get to the entrance eventually. It might take a while. Okay, so that's it. I'll stop there. So let me stop recording. But that is the level at which I would ask you guys to do your tech presentation.